Alright, let's discuss the six trigonometric functions and whether they're even or odd. And we'll begin with the sine function. So we're looking at, let's say f of theta. Let's say the input to the function is an angle theta, since we're dealing with the trig functions. And I want to determine if this function is even or odd. And in order to do that, I need to evaluate the function at f of negative theta and see what that equals. Well, if we consider, let's arbitrarily choose some angle theta that puts us over here. So this is positive theta. Negative theta would put us down here. And the sine function deals with the y-coordinate and the hypotenuse if you drew the reference triangle. You can see that these both have the same y-coordinate, except that this one's is negative and this one is positive. So f of negative theta, by the way, so f of negative theta is going to be the same as f of theta, the y-coordinate up here, except it will be the opposite, right? Because this is down, so it'll be the opposite value. Okay? Therefore, since f of theta is sine of theta and f of negative theta is the opposite of that, sine of theta is an odd function. Similarly, its reciprocal, let's call it g, cosecant is odd because it's simply 1 over the sine of theta. As you plug a negative in for theta, you'll get a negative in the front over here, making this an odd function as well. Okay? So sine and cosecant are both odd functions. Now let's do the same analysis on the cosine function. And since I still have my theta and my negative theta here, I want to compare cosine deals with the x-coordinate. And both of these points have the same x-coordinate, and they're both negative, so they both have the same cosine value. So the theta and the negative theta both have the same cosine value, therefore cosine is an even function because whether you plug in a positive or its negative angle, you get the same cosine value out. Okay? So similarly, its reciprocal, secant, is also even. Okay, so we have sine, cosine, and the reciprocals, cosecant and secant. Now we need tangent and cotangent. So if f of theta equals tangent of theta, we could rewrite that in terms of sine and cosine, sine over cosine. And therefore, whenever we want to find f of negative theta, as opposed to using the unit circle or the coordinate plane to determine if it's even or odd, we can do this using just algebra. So f of negative theta is going to be, I'm going to replace everything up here with negative theta, so sine of negative theta over cosine of negative theta. And since sine is an odd function, the negative is going to come out and go to the front. We know that sine of negative theta is the same thing as negative sine of theta. And cosine of negative theta, well, since cosine is an even function, it doesn't matter if you plug in theta or negative theta, you get the same thing as cosine of positive theta. So this is the same thing as negative sine theta over cosine theta. So look, if you compare the original function, f of theta, to the other function, f of negative theta, you get the opposite of the original function. And that makes sense because it involves sine and cosine. So that means tangent is an odd function because the output is opposite when you plug in a negative input. Similarly, its reciprocal, cotangent, is also odd because it's just the reciprocal of this. If you flip it, you still have the negative here.